This section of your Fleet School training is designed to introduce you to the importance of lube filtration. You'll learn the types of contaminant found in lubrication oil, and you'll learn about lube filter performance. You'll also learn about filtration techniques and be introduced to Fleetguard's line of lube filtration product solutions. When you've completed this course, you'll understand the importance of lube filtration. You'll know the type of contaminants that can be present in lube systems, and you'll learn lube filter performance measures. You'll also learn lube filtration techniques. Finally, you'll be introduced to Fleetguard's product solutions for lube filtration. Engine lubricating oil contacts more critical components of the engine than any other fluid. The role of the lube filtration system is to remove impurities and contaminants from the engine's lubricating oil. If the lube filters are not doing an effective job, engine life can be radically shortened. Modern diesel engines designed to meet stringent emissions regulations and achieve long service life utilize precise fits and clearances to accomplish these goals. Lubricating oil allows internal components of an engine to keep moving by separating them from each other. In addition, engine oil removes heat, forms a seal between the cylinder wall and piston rings, cleans the internal surfaces, and transports debris to the filter or filters, allowing it to be removed from the system. The function of a lube filter is to remove and hold unwanted contamination from the oil, increasing system life, reducing total operating costs, and saving money over the life of the engine. It's not as easy as you might think to keep the oil in an engine clean. Inside the engine, the combustion process, where fuel and air are burned to generate power, can generate contaminants that enter the lube oil. Other sources of contaminants also exist within an engine that can all lead to premature wear and possible component failure. Contaminants in lube oil fall into three categories. The first category is the organic components, otherwise known as sludge. Sludge can be composed of unburned fuel, rosin deposits, solvents, water, or soot. The secondary category includes the inorganic contaminants, generally categorized as dust. These contaminants can be dirt, wear materials from the engine itself, and used oil additives that have begun to break down. Finally, the third category is the acids generated as byproducts of combustion in the engine. The overwhelming majority of contaminants in the engine are organic in nature. As you can see from the chart, 75% of contaminants in a typical sample are organic. Only 25% are inorganic. As you learned previously, organic components, commonly known as sludge, make up 75 to 80% of total oil contaminants. Soot, for example, is a component of sludge. Sludge harms the engine by increasing the viscosity of the oil, making it thick and sticky. This increased viscosity leads to increased engine wear and lower fuel economy. Sludge also quickly plugs the oil filter and causes cold flow start issues. The inorganic contaminants, commonly known as dust, cause wear in an engine and make up 20 to 25% of the total contaminants found in engine oil. Most filter manufacturers focus on the dust holding capacity of their products. This measure does not correctly represent the performance of a filter. A superior lube filter is able to capture and contain both sludge and dust from the oil. Just removing the dust and leaving the sludge is paramount to leaving 75% of the contaminants in the oil. Unacceptable. To determine the correct lube filter required for your application, you must understand lube filter performance. There are three measures of the performance of a lube filter. The first is efficiency. The efficiency of a filter is the smallest size of contaminant the filter must capture all of the time. Also important is the capacity of the filter, which is simply the amount of contamination the filter is able to hold. The final measure of performance is the cold flow ability of the filter, which is the measure of the restriction of the filter under certain conditions, such as low ambient temperatures. Higher oil flow restriction results in delayed oil flow to critical engine components, causing increased engine wear. A good lube oil filter achieves an optimum balance between efficiency, capacity, and cold flow ability. If a filter doesn't perform well for all three measures, it will not adequately protect your engine. In many engine applications, and especially severe service vocations, more than one lube filtration technique must be used to remove all of the harmful contaminants. There are three common oil filtration methods used on new technology engines. The first is full flow filtration, which was invented over 50 years ago. It has evolved from a cotton bag fastened around a steel support structure to pleated cellulose media cartridges and a variety of filter media packaged in spin-on filters. Full flow filtering simply means all the oil flowing from the sump is filtered before going into the engine. This technique is the simplest and most straightforward. It's not always enough, however, so bypass filtration was invented. By diverting a small portion of the oil flow away from the lubricated engine components, a steady stream of oil can be super cleaned and returned directly to the engine sump. Over time and through turnover of the engine sump, the super clean oil contributes to improved oil cleanliness. The result is reduced engine wear rates and longer operation at peak performance levels. The third technique, combination filtration, utilizes both previous technologies in a single system. There are many aftermarket bypass systems, but most require mounting a separate filtration device on the engine and routing plumbing from the engine to the bypass filter and back to the engine. New technology combines both full flow and bypass filtration in one filter unit. The filter is fully self-contained with no extra plumbing required, which means no opportunities for hose issues or fitting leaks. In addition, this technology does not rob oil flow from the engine and divert it to the engine sump. The super clean oil is combined with the oil from the full flow portion of the filter, and all the oil is then sent directly to the lubricated engine components. Many different types of media are used to filter oil, depending on the specific circumstance. Pleated paper or cellulose is a natural material and is the most commonly used media material. Pleated synthetic media can be made from glass or various polymers. Depth media is tightly packed shredded paper, cloth, and wood chips. The densely packed organic materials filter not only the solid particulates, including catalyst fines, but semi-solids, petroleum gums, asphaltenes, and other organic compounds through absorption by the depth media, which acts more like a sponge for contaminants rather than a screen to capture them, as in a cellulose filter. Stacked disc media is always used in conjunction with other media. The stacked disc media is used to remove sludge, the most common contaminant in a lube system. By removing the sludge from the oil before it reaches the full flow media, the service interval of the filter is extended. Finally, wire mesh strainers are used for larger particulates. Synthetic media provides higher capacity, greater efficiency, and less oil flow restriction than traditional cellulose. Cummins Filtration has developed its own in-house production of synthetic, multi-layered media called Stratapore. Stratapore media is made using a melt-blown process, and polymers are used as the base material instead of glass. In addition, Stratapore is a layered media. Each layer acts as a separate filter, each with a smaller micron rating. This layered construction gives the Stratapore filter a gradient density, filtering out finer and finer particles as the air or fluid passes through the layers of media. Stratapore has a micron range from 2 to 25 microns, depending on the application. Compared to the average 40 micron rating of cellulose media, the Stratapore media delivers much greater performance. Regardless of the filter selected, all Fleetguard replacement oil filters meet or exceed OEM specifications for the wide range of diesel engines in operation today. In addition to its line of standard filters, Fleetguard offers a range of high-performance filters. These filters incorporate synthetic media and provide superior engine protection. The Venturi Combo Lube oil filters use Stratapore full flow media combined with stacked disc bypass filter technology, eliminating the need for additional plumbing to utilize the combined technologies. Remember that Fleetguard products, including high-performance filters, can be used as part of an extended service interval program to help operators reduce their overall operating costs. By utilizing a combination of filtering technologies, The Venturi Combo Lube Filter holds a clear advantage over standard filters. One of the most important features of the Venturi filters is the increased sludge holding capacity. The bypass media protects the pleated full flow media by holding up to 2/3 of the total contaminant, resulting in longer overall filter life. The combination of full flow and bypass filters increases the effective capacity of the filter. The benefits of using the combined technologies are clear. Venturi filters have longer service intervals, which means the engine can run longer, and longer service intervals also mean reduced maintenance costs. All in all, that adds up to lower overall operating cost because there is less downtime and more uptime. Looking inside the Venturi filter, you can see the stacked disc bypass media and the Stratapore filter media. The unique design of the Venturi tube directs more oil flow through the high-efficiency stacked disc section without compromising the cold flow ability of the filter. So, let's compare the types of lube filters. First, there are cellulose filters. They provide good protection. Cellulose has good efficiency, which provides wear protection and lengthens engine life. These filters are appropriate for applications with minimal oil degradation and sludge formation and are very cost-effective. For better protection, there are Stratapore filters. These filters provide extended engine life and have superior small particle removal capability. They also have improved cold flow characteristics due to the filter media fiber size. Stratapore filters attain OEM service intervals and beyond for lower operating costs. For the best possible lube oil filtration, there's the Venturi Combo filter. It has extended engine life due to small particle removal, but it also has sludge removal capability for cost-saving oil change interval options. The combination of sludge and particle removal provides longer overall system service life. Great equipment should be backed by a great warranty, and Cummins Filtration real-world warranty is coverage beyond the competition. This warranty provides non-prorated coverage, giving you full replacement protection. If a Cummins Filtration product defect ever necessitates repair of the engine or components, the Cummins Filtration warranty covers reimbursement of reasonable cost to repair or replace, whichever is less, the damaged engine or components. The real-world warranty also has features you won't find in the competition's warranty, like being uncomplicated and easy to read and understand. What about being able to read it in your native language? The real-world warranty is available in multiple languages, and it's backed by Fleetguard's industry-leading response time. No matter where you are, this warranty provides global coverage for Fleetguard filtration and cooling system products and the customer assistance you need to get things done and get on with your day. Now that you've completed this section of your fleet school training, you should know the importance of lube filtration, which is to remove unwanted contaminants from the oil in order to protect the engine components and increase engine life. You should be familiar with the types of contaminants in the lube system, including organic, sludge, inorganic, dust, and acids. You should understand the 3 lube filter performance measures: efficiency, capacity, and cold flow ability. You should have learned about the different lube filtration techniques, including full flow, bypass, and combination filtration. Finally, you should be aware of the Fleetguard line of product solutions for lube filtration, including Stratapore, Venturi Combo, and stacked disc bypass filters.